Um, okay. I, yeah, I'm trying to. Okay. I'm as Dr. Sid introduced. I'm Farshid Faraji, an executive committee member of Rescue Simulation Liga, together with Dina and Nikki. We're going to have an explanation on Rescue Simulation Liga. Um, uh, Dina and I will explain about the agent simulation, and Nikki will talk about the Robocup virtual robot uh, simulation they get. Um, I'm going to have a brief um, explanation about the Robocup, as I mentioned here. Um, then I will go to the rescue simulation. As you may know, the Robocup is an international poster and to foster artificial intelligence and robotics in different socially significant domains. It was created in 1996 and it is managed by Robocup Federation. Initially, it focused on artificial intelligence and robotics for enable robots to play soccer and advance in the field of robotics. Then other ligas like the red simulation added to this event. And you can see there are more than 40 countries and 3,000 participants everywhere participate in this event. And there are different type of activities here, like robots that active in home assistant, and the others that are active in industrial um, phases. So, the RoboCup Rescue Simulation League was created a little bit after the establishment of RoboCup. It was created in 1999, and it's focused on research and developing the socially segment of natural disaster. The RoboCup simulation use of artificial intelligence to support planning and decision making of disaster human urban setting, and its mission is implemented through, as you can see, three different activities. The first one is to provide a simulator that can realistically simulate natural disaster in order to enable this and support the disaster response planning. And as you can see, the second type of activity is to evaluate benchmarks for response plans elaborated by policymakers to act in real disaster situations. And the last one is that is main part is to organize competitions in order to put together the researchers and developers together to working on the natural disaster domain. This presentation will be mostly focused on the agent simulation. As you can see, there is a three type of competition in this Liga: agent simulation, infrastructure, and virtual robots. If I started with agent simulation, the Rescue Agent Simulator is a computer simulation platform that can, as I explained before, realistically represent natural disaster scenarios. It can comprehensively represent all the situations that may happen in a natural disaster. It involves the primary evaluating the performance of agent teams on different disaster scenarios in a RoboCup rescue simulation platform. So it can be used as a test bed for evaluating the effectiveness of rescue policies and strategies, and as well as for defining new strategies for elaborating the resources. There are a different type of research problems in this domain. I bring some more important of them here. As you can see, the most important of them are task allocation, collision formation, cooperation among the software robots, distributed and centralized control, communication, and clustering. And if I mention some challenges here, the decision-making algorithms, task allocation methods, multi-agent coordination and team formation methods, pathfinding, and search algorithms are the most important challenges in this domain. Well, if I now I'm going to give detailed information about the rescue simulator, the agent simulator. The rescue simulator is composed of an environment, as you can see here, that is usually represented by a map corresponding to a city like this one. This is a city of Kobe in Japan. The city represented with the roads. These are the roads, as you can see here. And different buildings that will have different characteristics and materials that they are built up. There are passive entities that exist in this environment, but the simulator also is composed of active entities. And these entities, we call them agents, and they are represented by these colored circles. As you can see here, there are different type of different colored circles: blue one, red one, white one, and we call them agents here. The green ones is represented as civilians in the environment. Civilians are individuals of the victims of in the disaster, and they can be free. That they can go by themselves to the rescue shelters, or they can be trapped inside the buildings, or they can be trapped also in some blockades on the street. As you can see, there are black signs on the roads. These are blockades that prevent agents from moving to navigate on the environment. The blue ones is police forces, and the police forces is responsible for unblocking the roads. So their main task is to clean up the roads in order to allow the other agents to navigate in the map more freely. And then we have the red ones. As you can see here, they are fire brigades, and the fire brigades are responsible for unburying the civilians from collapsed building and release them. Then the ambulances, the white circles, are responsible for carrying the buried civilians from the buildings to the shelters. We have as you can see here, there are some shelters in different places of the map. So the ambulance teams transport these injured entities from the buildings and other locations to the shelters. So all of these entities that I mentioned are active entities, and they have some characteristics that tries to reproduce or at least mimic the human characteristics or features. For instance, we have here we have an environment, and on the top of environment we have these entities. We call them software entities or agents that controls of each one of those active entities in the environment. These entities, they can perceive the environment, and they have a range of perception, and they can perceive the environment and what is going on in the environment. They can create some beliefs about the environment and about the other agents and about the other entities that exist in the environment. Then with that information and with that beliefs, they can make some decisions on the environment using different mechanisms of decision process. The decision process mechanism may be designed in different ways in order to represent strategies that are designed by the planners. Once the agents decided what action to perform, they can actually act on this environment, and the actions can be proactive or reactive. Usually, in this environment, we have more reactive actions where the agents can perceive environment and some change in the environment and react to that change by performing some actions. Um, Also, in this environment, we have a communication um, uh, among the agents, since the perception of agents are limited in a range, and so they cannot perceive all the environment. And to do so, to share their information, they use a communication tool here, and by this communication they can share their beliefs and their acts, and also they can exchange information about different decisions that they make on the environment. um, um, uh, these different features allow design these different active entities that I mentioned in the previous slides. So we have different types of active entities in the environment. Um I, I summarized them here. The first one was the ambulance team that are responsible for transporting civilians from location to the shelter. The fire brigades is one, which is responsible for rescuing the civilians in collapsed building, and the police forces that is responsible for unblocking the roads to allow entities to navigate through the map. And of course, we have civilians here in the environment that represented the green when they are healthy, and the black when they are dead. So that there is different phases in intermediary that indicates the decay in the health of civilians, and that is what need to be prevented by the fire brigades and ambulances when they are unbury the civilians from debris, and also transport them to the specific shelter. In addition to these active entities, and also and in addition to buildings and roads, we have also some other entities um, um, that are central entities in this environment: ambulance centers, fire stations, and the police forces, which they have a means of central control that can give some guides to the active entities like fire brigades, police forces, and ambulance in the environment to have a better decision. Besides that, there is refuges or shelters in the environment that agents, that civilians can be transported them to make treatment and stop dying. Well, my presentation finished here. I will ask Dina to explain more technical details about the simulator. If you have question until here, I can answer you. If not, Dina can start the rest of presentation.
Thank you, Farshad. Hi, this is Dina. I will now share my screen. Okay, can you see my screen?
Yes.
Yes, we
All
can
right,
see your screen.
thanks, Farshad. Thank you. So I will share more about the rescue simulator. So continuing on what Farshad said, so the simulator is structured as following. So we have the disaster simulator, simulators which simulates earthquakes or blocked roads or collapsing buildings. And we have the geographical information system, which has a set of maps for different cities. Each map has a different city and has a different disaster scenario. And we have the viewer that shows the progress on the map each time step. And I will go through that in the following slides. And we have, of course, the civilians that we are trying to rescue throughout the simulation. And those are the agents that the teams implement, the types of agents that communicate the simulator components using the kernel. So initially, when the run starts, what we see is the map in its initial state without the disaster scenario. So it's only a set of roads and buildings, and the agents, civilians in green, police forces, fire brigades, and ambulance teams in their initial locations. And then when the simulation itself starts, then we start to see more details about the disaster scenario that we're facing. So we can see the black roads, those are blocked roads that the police agents should clear. And we see the buildings with a light gray color, which means that the buildings are good, or dark gray color, which means that the building is collapsing or collapsed. So those civilians in the dark gray buildings need to be rescued. They're buried and they can't move. And we have the refuge, which is the safe place or the shelter that the civilians need to go to. And as the cycles progress, the disaster gets worse, and the agents need to cooperate and to work faster to rescue as much civilians as they can. So police forces are responsible for clearing the blocked roads. Fire brigades are responsible for rescuing, and ambulance teams move the rescued civilians to the refuge. And by the end of the this is an example of how by the end of the simulation the map looks. So we can see that most of the blockades are gone from the roads. So now only few blockades remain. So this means that basically most of the road, this is the first important step to happen, because without this, the rest of the map. Once the roads are clear, we can see that many of the civilians are at the refuge, which means that those have been rescued. We can also see civilians here that turned black, which means that those civilians died in their buildings. And the more civilians are rescued, the higher the score by the end of the simulation. So the competition runs for 4 days. 2 days for the first round, which is the preliminary round, 1 day for the semi-final, and 1 day the final. Each stage of those has a number of maps that we run. So on the first on a round, we can run like 8 or 9 maps, for example. And based on the number of participants, the number of teams participating, let's say if we have, for example, 12 teams, then maybe 8 teams will move to the semifinal, and then 4 will move to the final, based on like the number of participants and their scores during those days. And each team has to present their implementation to the rest of the teams. And they have to present their strategy and what they did. And this presentation is very important, so it counts as one of the maps. So for example, in the preliminary round, if we have 8 maps, there will be a 9th map, which is not an actual map. It's basically the score of the presentation. And the presentation counts in all the rounds. So it's important to present the ideas in a good way that benefits the other teams. One of the important rules in the competition is that we can't have a shared memory in any form between the agents, including static memory accessible to all the agents or direct function calls between the agents, or writing files for use by other agents during the running of the simulation. The only exception to the files rule is that during the pre-computation phase, one agent of each type is allowed to pre-process the map and the scenario-specific data and store it in a file to be used in the simulation phase. In the pre-computation phase, as we've seen the first screenshot, we don't have the disaster scenario yet. We only have the map itself as a set of roads and buildings. So the pre-computation phase doesn't include the disaster itself. It only has the map. And this is where one agent of each type can do some computation to maybe cluster the map or group the buildings and roads, something like that. But no shared memory or no shared data among the agents during the simulation itself when it's running. For the implementation of the teams can implement their agents in Java or in Python. The simulator itself is in Java, but the agents can be in either of those two languages. It can be Java or it can be Python, and we provide a sample agent in both languages for the teams to get started. During the competition, in the venue of the competition, our setup is as following. So we have 4 clusters. Each cluster has 4 machines, one that is for the server for running the simulator and 3 for running the agents. We have public screens to show the maps during the simulation when it's running. And usually we are running different teams at the same time, maybe on the same map, and we can see them running in parallel and compare the scores. So this is all for the agent competition. We have another competition, which is the infrastructure competition. The infrastructure competition is about presenting tools or simulators related to disaster management. The aim of it is to evaluate enhancements for the Robocup Rescue Simulation League environments. So it can be improvements to the Asian development framework or to the virtual robot simulator, or improving the sub-simulators that we use to simulate the disasters. So any ideas are welcome to improve the Rescue Simulation League in this competition, basically. So this is all that we have for the agent and the infrastructure competition. If you have any questions, I'm happy to answer. If not, I will hand over to Nikki to talk about the virtual robot competition.
Okay. Thank you, Dina.
Thank you.
Nikki, if you're ready, you can start the presentation.
Yeah. Just a second, so I share my screen. Can you see my screen? Yes? Okay.
Yes. Okay.
Yes.
Now. Okay. So, hello everyone. My name is Nikki, and I'm one of the TC members of this year's Robocup competitions. And I'm gonna talk about the virtual rescue robots league. So, what this competition is all about is that, first of all, a disaster has happened, just like the agent competition, but this time it's a bit different. So we're usually not in the whole picture of the city, but in a building or a smaller environment, like a building including its garden, or like indoor and outdoor together. It is very much inspired by the Rescue Real robots, and it's focused on realistic sensory and actual path planning. And in these pictures, you can see some examples of the environments that have been destroyed by the earthquake or some other natural disaster. And the robots are sent into this environment to explore it and find some possible dead and alive victims. Okay, so why would we even bother with virtual robot simulation when there's already a real robot simulation, real virtual, real rescue robot league? The difference is that, first of all, it's much easier to install. So if you want real robots and real environments, you cannot destroy a whole building just to send some robots in and do some tests. So the installation is easy because it's simulated. The second thing is that it's completely open source policy. And of course, if you want to make a real area in the competitions, you have to stick to the environment that is given in the fair. But in the simulation, you can build much larger areas, and you can send the robots to explore the whole big area. And also, building each real robot takes a lot of financial resources. So building 1 or 10 simulated robots doesn't matter in the case of money. And also, you can prepare very many different scenarios for the multi-robot exploration in the simulation. And also, first of all, before even thinking about building those real robots, you can first design and test them in the simulator. So what kind of resources do we have? First of all, we have 3 kinds of different robots. First of all, there are the 4-wheeled ones, as you can see in the top left corner. Then there are the aerial ones and the crawlers. And the type of sensors that they use are the laser scanners, the odometry, and the IMU. And then there are the RGB and thermal cameras. And the types of environments that we simulate are the indoor and multi-floor and the outdoor ones, which are each of them have different challenges for the robots. So the main problems of this league are, first of all, mapping and SLAM. So the robots have to make a very good map of the environment to report to real rescuers. Also, there is the robot navigation. So the robot has to avoid all the obstacles of the environment. Then there's the victim detection, that if the robot sees a victim, it actually understands that that's a victim and can decide between the dead ones and alive ones. And there is a multi-robot exploration. So if more than one robot is sent into an environment, how do they manage to not explore one part of the map twice, and how to communicate with each other? And yeah, there are still very many open projects. For example, the 3D mapping or the autonomous exploration of the aerial robots, the sensor fusions and robot navigation. Also, there is the movement detection of victims. So one way of finding out if the victim is still alive or is dead is that it moves. So if it moves, it's alive, and the robots have to be able to detect that motion. And then there is, if there is a fire, an environment. Sorry, can you hear me? Despite the
Yes.
COVID?
Yes, go
we
ahead.
can hear.
Yes.
Okay, good. Also, if there is a foggy environment, for example, there has been a fire or something, then the robots have to be able to still detect the victims. And then there is the victim behavior recognition. For example, is the victim sitting? Is it standing? Is it moving around? Is it trying to get the attention of the robot? And then there are the distributed planning for multi-robot exploration and distributed learning in multi-robot exploration. And of course, last but not least, there is the exploration in multi-map floors, where the robot has to distinguish between the two floors of the building and try to make a distinct map for each floor. So that's the first part, and the second part is about the rules and regulations of this competition. First of all, the challenges. There are 3 distinct challenges, which are the main ones of this competition. First of all, there is the victim search challenge, the mapping, and the exploration. And what is the mission? So first of all, the competition starts. The missions are that the maximum exploration by rescue robots is important. Then there is finding alive and dead victims. Then there is generating a map of the unknown disaster environment and marking important information of the generated map. For example, if the robot finds a victim, it has to mark it on the map. If it's dead, it has to mark in a distinct color from when it's alive. For example, the alive ones are marked in green and the dead ones are marked in black. Then there are the rescue scenarios, which are indoor and outdoor. As an example of the previous years, the upper left picture is a simulated environment of a disaster, which was in 2017 Nagoya competitions. And Yildiz University drew this map, which you can see in the top right picture. And they also marked their trajectory and the places where they saw the victims. And the lower picture shows how this victim detection is done. So the robot gets close to the victim, detects it, and if it's alive, it just stands there or just passes by, depending on the rules. Okay, so the competition is like this. There is 20 minutes for each team, for each round. There are the primary, semifinal, and final rounds. There are 3 awards, so there's a trophy for the first and second and third places. Then there are the round informations, which are the map size and allowed robots and allowed sensors. And they are released only 5 minutes before the start of each round. Also, there are 2 types of holding of the competition. So last year we also held the competitions via cloud because it was virtual due to the pandemic. And this year we are planning to hold in both in the hybrid form, so online and local. Also, there is the simulation environments, and all the team run their codes on the same workspace. Then there is this formula for calculating the score of each team. As you can see, finding more alive and dead victims is an important factor, and also the amount of map that has been explored. Yeah, and also the difficulty of the map is an important factor. If the map is very difficult, like it's too floored or it's indoor and outdoor, it has a higher score in the final score of each team. Then there's the technical talk, which is the third part of my presentation. So here we see that the system overview, there is a virtual robot simulation, which includes Gazebo, and the robot models, the sensors, and the world maps. So the robot models and sensors and the maps are implemented into this Gazebo environment. Then it is run on the local workstations or cloud simulators, depending on the type of the competition. If it's local, then there's a local network, and if we use these cloud simulators, we use the internet, and the clients, which are the teams and their robots, connect to this communication infrastructure, and the competition is held like this. And the local workstations have to have these specifications, like special GPU and Ubuntu 20.04 LTS and ROS2 and Gazebo 11, or if it's on cloud, it has to be either on the Construct Sim or AWS. So last year we worked with the Construct Sim, and this year we're trying to use AWS as well. So in the previous slides, I talked a lot about Gazebo and ROS. So I want to enlighten a bit more about what these things are. So Gazebo is a robot simulation environment. It's an app used to make it makes it possible to test these algorithms, and you can also design robots. And yeah, it has a lot of benefits. For example, it's very it is utilized by 3D graphics, for example, shadows and high quality lighting. Is it still hard to hear me, or is it okay? Because
That's okay.
okay.
I can hear you.
Also, it has very high performance physics engines. You can import many sensors and noise models, as you can see, for example, in the pictures on the right side of the slide. They're very realistic robot models, which have different kinds of 3D designs, and they even have shadows, as you can see. And then there are plugin support, which causes portability, reliability, scalability, flexibility in the software development. And then there is a high robot model support, and then there is the transport communication. And the best part of Gazebo is that it's also supported by the cloud simulators like AWS and the Construct Sim. So even if we want to run the competition completely online, we can still use this. Then I talked a lot about ROS. So ROS is a set of software libraries and tools that can help you build the robot applications. In order to we use ROS because the teams don't, so that the teams don't worry about the basic problems anymore. For example, mapping and exploration. So these are all libraries that are included in ROS, so that they can focus on the more important topics. For example, multi-robot exploration or victim detection. The good points about ROS are that it's been used and tested for over 10 years, and also in robotic industry. It shortens the time to market because it provides all the tools and libraries and capabilities. It's multi-domain, also it's multi-platform. You can use it in Linux and Windows and Mac. And it's 100% open source. It's also supported by ROS simulators like Gazebo. And especially with ROS 2, there is an industry support for the ROS operating system. Then the Construct Sim, which is the cloud simulator, which I explained about. And it is very good for remote competitions like last year. It supports different programming languages like C++ and Python. It supports different Gazebo and ROS versions. There are many courses that you can use if you use the Construct Sim. And the best thing about Construct Sim, in my opinion, is that there is no operating system installation required, so you can just click and insert your code and start programming and simulation, unlike local computers where you have to do some other steps as well, which is explained here. So first of all, if you want to work on your own computer, you have to install Ubuntu. In our case, it's 20.04. Then you have to install ROS2 Foxy, and then Gazebo 11. Then install ROS2 dependent packages like SLAM and Navigation Exploration. Then you simply open the wiki of our league and clone the GitHub project. And if you follow the instruction, you will easily build and run the source code. So what are the tasks which each team has to do? First of all, they have to design the base code, like a controller, the user interface and map viewer and stuff. Then they have to set up SLAM and navigation, exploration, according to the demos, which are also on the wiki site. And then they have to design the drone robot controller, implement the multi-robot exploration strategies and victim detection strategies. And the wiki that I was talking about all the time is the first link above. Then there are the other useful links which you can also use. For example, to the simulation website and the GitHub and the Rust 2 virtual robot project. And that's it. Thank you for your attention. And if there are any questions, I'm willing to answer them.
Thank you, Nikki.
Yes, we can hear you.
Yeah, thank you very much for your presentation. Dr. Tainova,
Sure.
Professor Pisik, that's all our presentation.
Any question from the floor? No?